Hey, Vlad here, devinside.com. Welcome to another video. Remember a few videos ago we wrote the map function, which sort of forced us to discover parametric polymorphism, also known as generics. Now map comes from functional programming, so I'm going to wave my hands a little and claim that functional programming caused us to discover parametric polymorphism. Now object orientation brings us subtype polymorphism, and functional programming brings us parametric polymorphism. Scala as a language blends these two together, and in this video we're going to see the true colors of this blend and discover the only thing that functional programmers hate more in this entire universe than mutable state. And no, the answer is not shared mutable state. As always, we're in the Ubuntu virtual machine and we have Sublime at the top and the regular terminal at the bottom, which runs SBT, which runs our tests. From the very beginning of this playlist, I try to drill this into your head that sets are data structures which are designed to only hold other data structures, not objects. And if you want to refresh the memory about the difference between them, remember the video about equality. I'm going to link it over here. Now, the big difference is that because sets have to guarantee that every element is distinct, they have to compare objects for equality, right? I just said object, but basically elements. They have to compare elements for equality. And this is much easier to do with data structures because objects, they employ things like mutable state or subtype polymorphism or inheritance, and data structures usually shouldn't, right? They can, but they shouldn't. Usually data structure is immutable and it has nothing to do with inheritance because it's not an object and has nothing to do with the object-oriented world. Now, there is a big exception to this one huge rule, I would say, and this exception is ADTs, right? Let's see. So we're in our test over here, and I'm going to go down to the bottom. Actually, let me just collapse this whole class. I'm just going to collapse it like this so that you see what I'm doing over here. So over here, I'm going to create a teeny tiny ADT. Usually for this example that, for this entire topic that we're going to discuss in this video, an ADT with animals is used, but I'm sort of sick and tired of it. So what we're going to do is we're going to have company roles, right? So we're going to have a company role. It's going to have an ID, which doesn't really matter what it has, right? So just for fun, it's going to have role name. We're actually not going to use almost anything from here. Get class dot to string. All right, and we're going to have two instances. So we're going to have final case class employee. Whoops, takes an ID, and extends company role. And just for fun, I'm going to have a function here, final def take vacation. Right, unit equals taking a vacation. We don't really care about that. We most of the time in this video we're gonna care about compilation. All right, so let's do another one. I'm sorry, final case class. This one is going to be a consultant. Consultant is somebody who can work for the company just as like a contract base. So he actually works for some other company. Right, extends. Can do CR like this, company role, and he has obviously different methods, like for example submit invoice, right? A regular employee has no business submitting invoices, right? All right, so here is my invoice, right? Now our tester should be still green and everything should still compile. All right, what's happening there? Oh yeah, I forgot a def. There we go. Now we're going to write a few tests which use these. So what we're going to do is I'm going to unfold the set suite again. I'm going to go down where we have the random string, and I'm going to add a few helpers that will help us to generate those employees and consultants. Okay, so we're going to have a private def random consultant, which will generate a consultant. Right, just going to go consultant like this, and remember consultant has an ID, which is just a random string. RS random string, and a company name is also a random string like that, and Scala reform is going to fix that. There we go. There was no need to jump around like this, but whatever. All right, so another one is going to be a random employee, which is going to be an employee, right, like this. Create an employee. It has only one attribute, but still random string like that. And we're also going to have a function that is going to generate both of them as a tuple. So we're going to say both roles like this. It's going to generate a tuple with an employee and a consultant, and it's just going to, as I said, just generate employee and random consultant like this. All right, this is all we need. So we're going to start with a test for the difference function. So let me find the first occurrence of difference. So this is where we have the test for the difference. In fact, let me make some more space over here. Difference, blah, blah, blah. This is the last one. And so we're going to add another one, another test for the difference. Okay, so it's going to be called difference on two sets with different types should yield a set with the common type, right? Okay, so we're gonna generate both roles and we're gonna deconstruct the tuple that comes from that. So we're gonna have an employee and we're gonna have a consultant, which is both roles like this, right? So what we're gonna have is we're gonna have an employee set, which is gonna be a set of employee like this, okay? And over here we're gonna have a consultant set. Right, it's gonna have a set with one consultant, right? Okay, so over here we're gonna say employee set, difference, consultant set should be employee set, right? Basically it stays untouched. And the same thing the other way around, just for fun. Difference, empty set, not employee empty set. That's, oh, come on, empty set. All right, should be consultant set. Right, and let's see what comes out. And what, not found value empty set. It's not empty set, it's employee set. What's wrong with you? There we go. So what we get is something really strange. So it says I found a set of employee, but I wanted a function that takes a consultant and produces a boolean. Now if you remember, sets are functions, right? Over here, set is a function. Now let's look at this again. So first of all, this is the second error message. If we scroll up a little bit, so at line 199, which is over here, we have an employee set, right? So element is an employee. So this set is a function from employee to boolean, but the problem is not here. The problem is over here. So the function difference, it wants another function, right? So if we go to difference over here, let me show it to you like that. It wants a function that takes an element and produces a boolean, and an element in this case is employee. So it wants a function that takes an employee and produces a boolean. Now a set that we're given it is a set of consultant, which extends a function consultant to boolean, right? So basically it says that a function that takes a consultant and produces a boolean is not the same as a function that takes an employee and produces a boolean, which is technically correct. And what we can do, so by the end of this video, what we will arrive at is that we can make a function that, so we will never make a function that takes a consultant and produce a boolean. We will never make a function out of it that takes an employee and produces a boolean. But what we should be able to do is, if we say over here that this is not a set of consultant, that this is a set of company role, now it should be better. See, now it's better. So if we go over here, right? Okay, so now all of a sudden this compiles, and you could say, well, not a big deal, you know, occasionally we have to annotate this with a type. Now, as I said, by the end of this video, we're going to fix this problem, but as of right now, you know, I'm going to concede, and I'm going to say, okay, let's do another example. So we're going to leave it like this. In fact, I'm going to comment it out just so that I don't forget it. And by the way, every time you comment out the test, never, ever, ever comment out the content of the test. Comment out and not the entire test instead, because somebody else can come in and can run your test and they will all be green and they will have no idea that actually the half of those tests are commented out. So never, ever, ever comment out only the content of the test. All right. So the next test that we're going to write is going to be a more problematic one. And in fact, I'm not going to write it here because this one has something to do with union. So let's find the test for union. It's over here, right? Union. Okay, this is the last one. Okay. Now I'm just going to call it union with variance because this entire video is basically about variance or variance annotations, and it's a technique of how to basically properly blend a subtype polymorphism with parametric polymorphism, but we'll see in just a second. In fact, you know, the content in this entire video is actually kind of complicated, but I hope that it will become clear at the very end. All right, so we have the same thing. We have the employee and the consultant, okay? So what we're gonna do is we're going to have a set of employee, and this time I'm going to annotate the types, not because what Scala infers is incorrect, but just for readability, so that you see exactly what's happening, okay? So let's do union, and we're going to unite it with a set of consultants, right? Now, it should be sane to assume that what should come out is a set of company role, right? Because, you know, employee is a company role and consultant is a company role, right? So it should be safe to assume that, you know, both of them are just inside over here, right? Consultant, like this. All right? But in fact, this doesn't compile. Let's see. Oh, it doesn't compile because of auto-completion. There we go. Employee, consultant. Okay, so now it doesn't compile for proper reasons, and my face is covering up a part of the error message, but it's not the important part, right? So it says, I found set of consultant over here, right? But what union wants is a set of employee. Let's find union, actually. Where is it? Did I miss it? There we go. Okay, so union is a bit less complicated because it doesn't want a predicate. It wants a set of element, but the set of element in this case is a set of employee, right? So it wants a set of employee, but it finds a set of consultants. So over here, obviously, I'm not sure if this is obviously. Let's see if we can actually do this, company role. All right, so over here, the same trick that we just used is not enough. Now it says, still type mismatch, right? It says, note, company role is a supertype of employee, but trait set is invariant, whatever that means, in type element. You may wish to define element as minus element or hyphen element instead. Okay, well, whatever that is, let's try. Let's go and let's see. All right, now we see 15 errors. So this is clearly not the way to go, and this is one thing that, you know, once you program at this advanced level, the compiler is trying to help you out, but it really can't. So it tells you, okay, try this thing, and let's see if it's gonna work. But you know, you try it, and then you hope that it's gonna solve all your problems, and it doesn't. So you get frustrated. Now, let's go actually back. Let's go back from, because this is not what we want to annotate anyway. Let's go from employee back to consultant, right? Now, let's think about this. Let me comment this out. Why is it even sane to assume that this is what should happen? Well, I would argue that this is sane to assume because we can manually construct it, right? So we can do manually set of employee, not empty. Please stop doing that. Employee, consultant, right? And this compiles. Now, just in case you're suspicious, we can also annotate the type, right? Company role. It still compiles. Now let's dig further. So how does this thing work? Remember, this is a var_rx method, but in fact inside of it, it has a fold left over the sequence from Scala collections, and it basically creates an empty set and adds every element one by one. So why don't we do that? Why don't we do that manually? Let's see. So let's comment this out because this, you know, this compiles anyway. We actually don't really need that. Okay. So let's do the same thing at the top, right? So we have a set of employee. All right, but instead of union, we're just going to say add. Let's add a consultant, right? And just to make sure, like, we can annotate this. This is a consultant. We don't really have to. I'm just doing this for readability reasons, right? So let's say the same thing. It should be a set of, and again, just for readability, company role, just to make sure also that everything that is inferred is the correct type. So we're going to have employee here, and we're going to have a consultant here. Let's see. Okay. Sort of tells us the same thing. It says, okay, type mismatch. I found a consultant, but I required an employee. Well, what about the company role here? Company role here. There we go. All right. Tells us the same thing. Okay, it says, okay, required employee, but you know, but you're giving it a company role. Now let's try to hack the add function. Let's look at the add function, which is over here, right? So it says that it wants an element. Now, how about we parameterize the add function itself? And we're going to say, okay, I don't want you to take the element. I want you to take an element or any supertype of element. And the way you write this is you name your type somehow. I'm going to call it super, right? And then you say, okay, it has to be a supertype of element. And this is called a lower bound. It is a lower bound. It says, okay, at least it has to be an element, or anything above is also fine. Now this type over here that is being put in is not an element anymore. It's going to be super, right? So we can put an employee here, and we can also put any company role here. Now what comes back is exactly what we want. We don't want a set of element. We want a set of super, which is potentially element, potentially employee, but it can also be company role. Let's see. Oh my God, it works. All right, so if that works, then why doesn't union work? Let's see if union now works with this. Okay, now it still says that it can do that. Okay, hold on. This is a consultant. Let's make sure that this is a company role, just so that we have fair game. And it's the same thing. You may wish to define element as -element instead. Now it turns out that this is actually the opposite of what I want to do, because what I want to do is actually plus element, and a bit later in the video I'm going to explain what the difference is and what the hell this means anyway, right? For now, let's just do the same trick to union that we did to add. Let me comment this out, right? Just so that everything compiles. Okay, let's go to union. Let's go to union. And let's do the same trick. So let's say that it doesn't take element, but it actually takes a super type of element, right? So it takes a set of super and it produces a set of super, because it seems like, this is exactly what we want. Now it compiles. Let's enable the testing here. Okay. And oh my God, it works. So the same trick worked, as was the difference now, because the annotation, in the beginning, this annotation of the super type was enough. Over here it wasn't enough, but we did a few tricks and now it's enough. So let's see what happens if we actually remove it back, right? If you remove it back, it's gonna say, whoa, now it wants us to do a plus element. What's up with that? All right, enough playing games. So what we can do is we can go over here and we can annotate the element type either with a plus or with a minus, right? And plus would mean that the set is going to be covariant in the element, in the parameter called element. Now, because set has only one parameter, it is going to be, we can simply say that the entire set is covariant. Now, what does it mean that the set is covariant? Well, it means that if there is a subtype relationship between the elements, right? So if A is a subtype of B, right? Or if an employee is a subtype of company role, then if the type is covariant, it means that a set of employees is also a subtype of set of company role, right? So employee is a subtype of company role, set of employees also a subtype of company role. Now you might wonder, like, shouldn't it always be like this? Because it sounds very intuitive, but in fact it's not always like this. Now in our case, we actually want it like that, and therefore we're going to spend the entire video implementing it. And we're going to talk about contravariance a bit later. So the first step is going to be to comment out this entire test. Let me comment that in. Let me comment that out. Okay. Now, before we can actually do this, we have to understand a few other things. Now, the problem is that this function over here, it is actually contravariant in the first parameter, right? It is actually covariant in the second parameter, but this doesn't matter. But it is contravariant over here, right? So it is defined as a function where the input type is covariant and the output type is where the input type is contravariant and the output type is contravariant. This is how it's defined. It's a class function or trait function. Now the thing is that, first of all, contravariant means that if A is a subtype of B, then a set of A is a supertype of set of B, right? So it's flipped. It's contravariant, right? We're going to talk about contravariance a bit later, right? Well, what you need to know is that over here we have a type which is contravariant in the first position, and over here we have a type that is invariant, so it's neither covariant nor this contravariant. And you can use two together, but you can't use a contravariant type together with a covariant type together with a contravariant type. So in our, if we try to do this, well, first of all hell is going to break loose, and secondly, in the end, we're gonna fight this. It's gonna tell us you can't be together a contravariant in the element and covariant at the same time. You can't do that. So what we need to do is we need to apply a very, very magical trick. And for this, we need to learn about the concept called implicits, which is a one of the high-end topics in Scala, and we're gonna have very dedicated videos for that. For now, all we're gonna do is a tiny crash course. So I'm gonna create a main method in the test subfolder, right? So usually you would have a main method in the in the production code, but we're gonna have it over here, right? And I'm not even gonna create it in Homegrown collections. I'm just gonna create it here over here, test Scala, and I'm gonna call it Scala. I'm gonna call the file Scala because by the end of this video, we're also gonna have examples in Java. All right, so scala.scala, okay, and I'm just going to have an object called, I'm just also going to call it Scala, extends app, okay, print line, hello world, over here, like this, okay. So what I can do now over here, I can do the tilde, I can do test, run, all right, so right now it's always going to run hello world, okay. Now, the crash course that you need to know is that implicits are a mechanism to glue seemingly completely unrelated types together. So we're going to create two types by employing two classes. They're going to be case classes because it's just going to make me, make me create the example faster. So we're going to have an apple, which has a weight in grams, which is ints, right? And also has a color. Apples can be like yellow and red and whatever. I'm not going to explain you what an apple is. We're not talking about the company, by the way. We're talking about real apples, right? So we're going to have orange, and I'm going to mistype it as orange all the time. It happens to be always. All right, so it also has a weight in grams, but it doesn't have a color, right? So now let's say that we have a function. A simple, very, very simple function. It takes an orange. I just warned you that I will, oh my God. I don't know why it's happening. Okay, so it takes an orange, and all it does is just prints it out. Print line orange, right? That's all it does. The code should compile now. Okay, it doesn't run anything. Okay, so let's create a function, and let's call this function. Okay, we're just gonna call this function, but we're gonna try to call it. Okay, so first of all, let's call it with an orange, right? So this is an orange, and it has a weight in grams. Let's do 300, right? So far nothing magical. Function wants an orange, we're giving it an orange. Now, what we want to achieve by the end of this crash course is that we want to be able to give it an apple. Now, in this example, you might be wondering why the hell would I want to do that? But it actually sometimes makes sense, and as I said, we're going to have videos dedicated for that. Yeah, so let's say that this is a red apple. Okay, so obviously it says, okay, it's a type mismatch, I want an orange, but you're giving me an apple, so what the hell? Well, imagine that we had a function, a simple function, nothing magical yet. We're going to call it apple can be used as orange, right? And all it does is basically converts an apple to an orange. So an apple comes in and an orange comes out, right? So all it does is it creates a completely new orange, and it uses the weight from the apple, right? So if we had this function, then we can obviously convert this apple to an orange just by calling it and passing it as a parameter, right? So Scala form is going to reindent everything for me, and now obviously it works, right? So we ended up passing an apple to this function by converting it to an orange first. Now at this point, implicits come in. If we mark this function as implicit, like this, and the compiler can find it, then what will happen is that if I copy this code, I'm going to paste it over here, then we actually don't have to do this conversion for us. Then we don't have to do this conversion ourselves. The Scala compiler is going to do this for us. Now, first of all, as I already said, implicits are a shady feature, so we already get warnings from the Scala compiler. So it says rerun with feature for details. So if I open the build file, and we're going to add some Scala C options over here, Scala C options, plus equals, and we're going to do the same. So this is going to be a sequence of options, and the first one is going to be feature, which has to be a string like this. Okay, so now we need to reload the project, and do the last command, which is test run. Okay, now we see the actual warning. Now it says, if I scroll up, it says implicit conversion. Hold up. implicit conversion method apple can be used as orange should be enabled by making the implicit value Scala language implicit conversions visible. And there are two ways to do this. This can be achieved by adding the import clause, so we can just import this, right? Or by setting the compiler option, right? So this is what we're going to do. We're going to take this, copy, put it over here. So we're going to leave the feature, and also we're going to have that, right? So now we're saying, you know, we know what we're doing, so leave us alone and don't produce warnings. What was the last one? Like this. Okay, so now the same code works without any warnings. Now again, we're gonna have dedicated videos for implicits, and for now I'm just gonna say a few tiny things. Like this particular type of implicit that we're doing over here is very, very dangerous. So please only use it when you know what you're doing. And you know, to add a little bit to the crash course, now how does this work? Now the compiler sees, okay, I have a function that wants an orange, but you're giving it an apple. So what it does is it looks for conversion functions from an apple to orange that are marked with implicits. You know, it doesn't go through all the possible methods that just happen to take an apple and produce an orange, right? So if I remove this implicit, it's not going to work, right? It's gonna show the same error as before, right? So it only touches the one that are explicitly marked with implicit, no pun intended, okay? And this function has to be available in the path where the compiler is searching for. Now, as I said, we're gonna have dedicated videos. We're gonna you know, go through this entire path. For now, all you need to know is that one of the places that the compiler looks at is the current scope, obviously, and the other one is the companion objects of either apple or orange, right? So why did we need this whole thing? And I'm gonna remove it, by the way, in a second. We need this whole thing because, as I said, we can't have the element as covariant and as contravariant, so we cannot extend the function, right? So let me actually leave this for now. Let's go back to running our test. Okay, so we can't have this. So what I'm going to do is I'm going to remove that. Right, I'm just going to comment it out for now. And now this function apply doesn't override anything. Okay, now when I try to compile this, obviously, you know, a lot of things are not going to compile because we want a set, you know, to be usable as a function. So what we're going to do is we're going to go to the companion object. I'm going to collapse that. We're going to go to the companion object somewhere at the very, very bottom over here, and we're going to create an implicit conversion, which will take a set and convert it into a function, and this will be safe. So we're sort of, you know, on one hand we're sort of tricking the compiler, but on the other hand, you know, I am entirely sure that this is safe. Okay, so we're going to create an implicit function, and we're going to call it set can be, by the way, the name of the function doesn't really matter, right? The compiler looks only at the types. Okay, so set can be used as function 1. Okay, now this function itself is going to be parameterized with the element. Right. Notice that there is no element in scope, so we're in the companion object. Over here, there is no element, right? So I could call it E if I wanted to. Okay. So it takes a set, which is a set of elements. Okay. And it produces an element to Boolean, right? So it produces this function, right? Takes a set, produces a function. Let me actually have it like this. Okay. Now, how is it going to do this? Well, it basically is just going to say set.apply, and that's it. Okay, now these things will compile now, but now if you see the test don't compile now. The thing is that when you're dealing with implicits, some rules for the type inference also change are also changing, right? So if you go to set suite 135, which is over here, right over here, what we need to do is every time we're using an empty function, like exactly like over here, right? In fact. Yeah, so the problem is in this line. So exactly like over here, we need to do something like this. We need to annotate the type. Now we can't use nothing, and to be honest, I have no idea why. Right? So if I put nothing over here everywhere, right, it doesn't actually solve our problem. But if I put something else, literally anything else, like for example string, and then it actually will solve our problem. Right? So now we have only 3 errors, and in fact we only needed that, I believe, in over here. Right, so we don't need to use the type over here, right? So we should still have 3 errors. Yeah, we still have 3 errors. So let me just go through all of them and fix basically the same issue. 138, which is over here, right? String like that. Next one is 172. 172. There we go. 172 over here, same thing. String. And the other one was 215. 215. There we go. String. Okay, so now everything works. So we don't have this inheritance relationship anymore, or this subtype polymorphism relationship anymore, but we have this this magical implicit that fixes the problem for us. Okay, so over here takes a set, produces a function. Remember, we have two tests that are commented out. The test for difference and the test for the union, which is somewhere at the very bottom. Right, so if I comment it in, it shouldn't work. Oh, actually this should work. So what shouldn't work is if we remove the annotation like this, right? Okay, now it doesn't compile. So let's comment it back in. Okay, so what we're gonna do is we're gonna make sets covariant, and after we're done with it, we're gonna uncomment these tests, and they should be green then. They should compile. I mean, as I said, we care mostly about compilation in this video. All right, so let's make a plus over here, right? And let's see what we need to fix. Because the Scala compiler has a so-called declaration site generics, which means that whenever you create a type, you specify, exactly how it should behave. Should it be covariant, or should it be a contravariant, or should it be invariant? Whereas a language like Java, and let's be honest, Scala is still mostly compared to Java. Java has call set generics, which is a big mistake. Anyhow. It's a big mistake because over here, you're sort of a library designer, so you're sort of like an advanced user, and people who use your library, they don't know that much about such complicated topics like this. So why should you impose this decision on them, right? Okay, so let's go through the errors, and it's actually not that many errors. Okay, first of all, line 6 was the apply. So basically everywhere we have to do the same trick as we already did, by accident, by playing around over here with the add function. So we need to say, okay, you can actually ask if the element that is contained is actually a super type, right? So this can be a super, right? So now it goes back to contains. Okay, so contains needs to have the same problem, the same solution, contains, right? And this is a super. Now 3 errors. Okay, now it complains about does not contain, obviously. Let's go here. Does not contain is basically, contains reverted. All right, 35 is the remove function. Over here, same thing. You can also remove that, like that. All right, and 68 over here, same thing. All right, at least the code compiles. The tests are green, and let's see now if you comment it in. It compiles and it works. And let's go down to the other one. Let's go down to the other one, to the other one, to the other one, to the other one. Where is it? Let me try to find it. Union. There we go. It works. So it works, and it also works if we don't use annotations at all. So covariance, it makes generics less rigid and more flexible, right? And covariance plays better with type inference. Right, so over here we don't need to annotate the types. Scala is able to figure it out on its own, so it knows, okay, this is a set of employees, this is a set of consultants, what should come out is a set of company role. Now we're going to comment out these two over here, and I know that this last transformation was kind of fast, and you probably don't really know, okay, what just happened. But basically we made exactly this possible that we wanted, right? So it basically allowed the compiler to treat the set of employees as a set of company role only because employee is a subtype of company role, right? We gave the compiler the permission to do that, and what it did was it made sure that we only use it in proper positions, right? So for example, this one is actually a contravariant position. Now remember that a set of function, for example, is also contravariant in the first element. Well, a method is basically a function, right? So this is also a contravariant position, and we had to explicitly go there and say, okay, I know that this is a contravariant position, but we explicitly allow you to pass in a supertype over there, right? So the compiler helped us out. In Java, this doesn't happen. Now, you might be wondering, like, when is it safe to make something covariant? And the answer is every time you have something immutable and it is sort of sealed or final, then you can just safely make it covariant. In fact, a lot of functional constructs, because they're all immutable and usually, you know, subtype polymorphism doesn't even exist they're naturally covariant, right? Anytime you have something mutable, just forget about it right away. Anytime something is mutable, make it invariant, and I'm going to show you an example a bit later. So for now, I'm just going to, you know, just so that this sinks in a little bit more, we're going to write another test. We're going to go to exists, and we're going to write another test over here. This is going to be a very long one, and it's basically just a bunch of examples of covariance now in this case. So I'm going to say exists was variance. By the way, I sort of forgot to mention that, you know, this whole video is not going to be like a, you know, like a full-blown tutorial on variance. It's going to be like a bit more like pragmatic. Like we have a problem, we need to solve it. Okay, so let's create our lovely employee and consultant, and we're going to have both roles over here, right? So let's see. Okay, let's say we have a set of employee. And in fact, you know what? I'm going to copy paste this because this auto-completion sort of makes me angry. Okay, so exists equals employee. This obviously should be true, right? And we're going to have another one where we're going to have a consultant over here. And because remember the video about equality, you know, this will compile. There should be a warning though in this case, I believe. Yeah, there is a warning. So because I don't want to have this warning, oh, by the way, it should be false. So the test should still be green, but it produces a warning and I don't want to have it. So I'm just going to comment this out and I'm going to say compiles, which, you know, is kind of sad, but it compiles with a warning. So at least we have that. Okay. Let me make this a bit wider over here. Now in the next few lines, let's be a little bit more explicit. So we're going to have an employee here and we're going to have an employee over here, and we're going to say exists, and we're going to do the same thing. Should be true. Again, we don't really care about the results of the test in the sense of you know, in the sense of runtime. We only care if this compiles or not. Right? So now I'm just going to duplicate this line and I'm going to say that this is a set of company role. They both should be fine. Okay. Now let's go here and we're going to have a set of employee again. Employee exists. Okay, now over here we're going to be explicit, more explicit with these functions, right? So it's basically going to be exactly the same functions, but with type annotations, right? So we're going to have an input, which is an employee. Input equals employee should be true. Okay. Okay, that works. Let's do the same thing with the company role. CR, like that. Now let's also try the company role over here. I mean, that one's sort of obvious, right? Now the next one is going to be interesting. The next one is going to be, I'm gonna duplicate that. So we're basically going through all the possibilities, right? So employee, company role, employee. Now this is the last one, and this one is actually should not type check. Now I'm just going to show you that it doesn't compile, right? It says, okay, I wanted a function that takes an employee and produces a boolean, but required a company role and produced a boolean. And this is where we arrive at the concept of contravariance, right? So it says, I found an employee. Let's just ignore the right side. It says, okay, found an employee, required a company role. Now we know that an employee is a company role, but because the function is contravariant in the first parameter, this relationship should actually be flipped, right? So it means that if an employee is a subtype of company role, then a function that takes an employee is actually a supertype of the function that takes a company role, right? Now it might be totally counterintuitive and you might be wondering why you should need something like this. Well, it actually totally makes sense. Let's look at a function like, for example, map. Remember, map sort of started to cause us these headaches, right? So a function that called map, it wants a function that takes an element and produces a result. So let's say that we have a set of employees, right? It says, okay, give me a function that takes an employee. Now, inside of here, it could call employee.takeVacation, for example, right? And this, or the function itself could do that, right? It could say employee dot take vacation, right? So when you're passing a function that takes a company role, this will crash, right? Because company role doesn't have this function. So it totally makes sense for it to be contravariant. In fact, let me show you this. What if we hack some stuff together? Over here, let's create a function called implicit def, and I'm going to say function 1 can be covariant in the first parameter, which it can't be, right? So we're going to say, okay, so let's say that there is some input type, right, and there is some output type, okay? Let's also say that there is a super type, which is a super type of input, okay? So we're going to have a function over here, right? It takes an input, produces an output, okay? And we want to convert it to a function that takes a super of the input and still produces the output, right? So basically, we don't really care about the output. In fact, in our case, the whole output is Boolean anyway, but still. So what we need to do here is to do a function as instance of, which is dangerous, and it is not correct. It will actually always explode. Super result. Sorry, not result, output. There we go. All right, now it compiles actually, right? But now this is an erroneous code. Why? Because over here we have an employee, right? Over here we have an employee. So let me show you this. I'm gonna copy that, and I'm gonna go over here and put curly braces around here. Okay, so obviously this function needs to produce a Boolean where input equals employee. But also, this is an employee, right? So we can do something before we do that. So let's say input, take vacation. Let's see what's going to happen. Oh my God, this is fine. You just said that it's going to break, but this is fine. Now, why is it fine? Well, it's fine because it just happens to be an employee inside. Let's add a consultant in there. So I'm just going to duplicate this entire line, right? And we're going to add a consultant over there. Oh my God, it's still fine. What are you talking about? It's not dangerous at all, right? Now, what happens with exists is, remember, as soon as it sees that the employee exists, it doesn't actually touch the consultant. Now, sets, they're supposed not to have any order, right? They don't guarantee any order, but the implementation actually has some sort of order, right? It puts the elements into some data structure, right? Remember our links, they're still assembled somehow together. Now, the API hides that fact, right? But the implementation is still there, right? Which means that if I flip that, if I go over here and I say consultant over here and I say an employee over here, it will actually touch the consultant first, and it will try to call take vacation on consultant. Now, even before that, this code will run over here, and this is the one that is dangerous, and this is the one that creates like gigantic headaches, especially for functional programmers, because subset polymorphism basically breaks equational reasoning and many other beautiful things. So what it says over here, it says class constant exception, right? So it happens at runtime. Consultant cannot be cast to employee, and this is why, even though we could hack some dirty magic, right? It's still a wrong thing to do. In fact, let me show you this. I believe that I discovered a compiler bug. Look at this. So now I'm just going to compile the test. The test compile. Look, if I don't even try to cast it, I'm going to do this. Compiles. Okay, let's see what happens if we run our tests. Nothing is happening. It's an infinite loop. It actually got stuck in there. So my CPU over here, because I have 4 cores, we have 25% of the CPU usage over here, right? So in fact, I'm going to have to kill this. I'm going to go back to SPT. By the way, remember in the video about recursion, we use the revolver package, which helps out in situations like this. Okay, so let me revert this nonsense. Let me just remove this ugly implicit def. Let me remove these tests over here, right? And let me just say that this expression that it should not type check. So Scala Test allows us to make sure that some code doesn't compile, or if you want to be a bit more explicit, that it just doesn't type check. All right, now let's add a few more lines to this test, and then have a discussion. So the tests that I'm adding now are basically exactly the same as these four, but in these four, we're going to not use functions. We're going to use sets, which implement basically exactly the same thing. In fact, you know what? I'm gonna copy these three. I'm gonna paste them over here. Right, so over here, instead of using the function, I'm just going to use a set of employee. Right, and let's do this. Let's do this step by step. So we're going to have a set of employee. All right. In fact, let me actually annotate the type just so that we're 100% sure that this is an employee. Right, and over here we're going to have the same thing, but we're going to annotate the type with a set of company role. Employee. There we go. Now, instead of fixing this one, I'm basically just going to copy paste that, and I'm going to say company role over here, right? And now the last one, which is, you know, sort of beautiful. So the last one, it basically mimics this one, but it will work. Now it works and it is not dangerous. Why is it not dangerous? Because the function that converts a set into a function is written by us, and we made sure that we're not doing anything funky with that element, right? We're just passing it through, right? And therefore no class exception can happen. It's sort of like a private thing that we're taking care of, and we're taking care of it, you know, with this test, right? So because we have this test, you know, we sort of made sure that no bad things can happen. And by the way, you know, this is a very complicated topic, so please correct me if I'm wrong about this, but I believe that this is very, very safe. All right, one of the last things that we actually can do is that because our sets are covariant now, we actually don't need to have a parameterized empty version, right? Because now we can have nothing here, right? So a set of nothing is now a subtype of set of any element out there, right? So we can just go and do nothing here. So we're gonna do it step by step, right? There's nothing here, so we can do an object here. So instead of class empty element, we're just gonna say object empty, right? And therefore over here we're just gonna return empty. You know, step by step. Okay, line 97 over here. So we could do empty.type over here, or we could just use the you know, the reference equality, right? So we could just do this equals empty, right? Should be exactly the same code, and maybe even that it should be the same code. Yeah, but I actually like this one because this one didn't compile when we changed stuff, so we were forced to take a look at it again, right? And now, because now this empty function doesn't need any of that, right? So it just it doesn't need the parameter, and it produces a set of nothing. Now this should cause a few problems now, because at a few places we're actually explicitly passing a parameter with that, right? So let's go through them one by one. So it's line 36. And I'm going to try to save some time, and I'm going to try to not compile like after every fix. So over here, we need to say that this fold produces a set of super. Set of super. In fact, this empty element was not entirely correct. Didn't make a difference though, right? So over here, we cannot, you know, help out the compiler with type indifference, because if we just remove this, we're still going to have, okay, how many do we have? We have 6 errors, right? So if I compile this now, we're still going to have 6 errors, right? So we need to help the compiler out and say, okay, this is actually a set of super. So now we have 5 errors found. Let's actually go from the bottom, maybe 143 over here. Okay, same thing. So we're producing a set of element over here, and therefore we can just do empty, right? Okay, it's actually kind of fast to let it compile. 1 to 1. Same thing over here. We're producing a set of result over here, so we can just use empty. Right, okay, 3 errors, 118, which is over here, same thing. Set of result, empty. Okay, 2 errors, 58. Okay, over here we're producing a set of element. empty. There we go. Okay, and the last one is at line 50. Over here, same thing. Set of element, empty. Now this should compile now, but the test shouldn't. Oops, what did I do now? Try to be too fast. All right, now the test don't compile, and it's because we're saying dot empty string, right? So dot empty string, like all of these places that do that, I'm just gonna mark all of them, and I'm gonna say dot empty. Okay, now only 2 errors left, 136. Okay, these ones are doing the nothing thing. All right, so now everything's fine and the tests are green again. All right, now we're pretty much done. We're just going to talk about a few problems that covariance, when used inappropriately, can cause. The first one is a very famous example. Arrays in Java are an immutable collection, and they are covariant for historical reasons, because in the beginning Java didn't have generics, and they really needed I needed a way to make arrays a bit more flexible. Now this means, and this is a very famous example, so what I'm going to do now is I'm going to create a Java main, remember as announced before, and this Java main will play with the company role and employee. So before I create this main, I'm actually going to cut this out. In fact, I'm not going to cut this out. I'm going to copy it and I'm going to comment this out, because I don't want to commit this whole those main methods, right? So I'm going to comment this out, and I'm going to put them over here. Let me actually collapse these, right? So I just need them to be in the production code axis. So I'm just going to put them over there. All right. So now what we can do is we can go to our production code over there. We actually don't need to go to the production code. We can still do it in the tasks. Okay. So let's go here and create a new folder. And let's create a folder called Java. And in there, we're going to create a file called java.java. All right. Like this. So over here, we're gonna import our package, right? Our homegrown collections, and please God help me to not forget those stupid semicolons. All right, so over here we're gonna have a public class Java, Java like this, and Sublime has templates. So Sublime, if I just type main and I press tab, it will generate the public static void main for me. So what I'm gonna create over here is an array. This is how you create arrays in Java. I'm going to call it employees, right? And we're going to create a new employee array. There's a bit of a shorter syntax for that, but I want to be explicit. We're going to create a new employee, and we don't have this random generation in scope, so we're just going to say some ID, right? So with a semicolon, that should work. In fact, let me switch to running. No, actually, I need to switch to test run. There we go. Okay, we have 2 of them, and I want to make this quicker, so I'm just going to comment out this whole thing. So I'm going to do Java. All right, so it ran. Now, this is a very famous example, and as I already said, it's usually you do this with animals, right? So again, arrays are immutable, and if we create another one, company role, right, which is roles. Now, because they're covariant, even though they shouldn't be, employees is a subtype of company role, right? So because an employee is a subtype of company role, an array of employee is a subtype of company role, right? So this is the line that is sort of evil, right? All right. So the next thing, freaking semicolon. Let's see. All right. Okay, so this line compiles. Okay, so arrays are an index collection, which means that first of all, it's sorted, and second of all, every element has a certain position. It was a 0-based index. So what I'm doing here is I'm saying, okay, in the first position, which is denoted by a 0, I want to put in a new consultant. Which should work, right? So we're creating a new consultant over here, another ID, another company. And there we go, semicolon. Now this should work, right? So because roles is an array of company roles, right? So we can add a consultant there. Let's see what's going to happen. What happens is an exception. So first of all, it compiles, right? So let me show you this again. Test, they compile. And this is a problem, right? Because in Scala, the same code is not going to compile. Okay, so let's run it. So it explodes with an exception called array store exception, right? So basically, every time you add an element to an array, it actually makes sure that the types match, which is a very, very inefficient way to add something, by the way, right? Also, Usually this example keeps going with this line, employee equals employee, employee equals employees 0. Okay, so this one retrieves an element from the employees collection, right? So basically, if this thing doesn't happen, right, then everything is fine. But if this thing does happen, I mean, assuming that it gets to this line at all, because it's not going to, because this is going to throw an exception. But if it did, then what is happening here is we're saying, okay, give me an employee which is at the first position, right? Give me an employee which is at the first position, but at the first position there's a consultant. I mean, sure, there's an exception, but still, it sucks, right? All right, okay, so let's do the same thing in Scala real quick. Let me comment this out. We already have a playground in Scala over here, right? So what I'm gonna do is I'm just gonna go to the bottom. Actually, you know what? I'm gonna throw this thing out. This was the implicit thing. Okay, so we're gonna do the same thing over here. Employees, which is an array of employee. Come on, employee, and we probably need to import homegrown collections, right? Okay, so this is an array, so we're going to go array, and let's be as explicit as possible, right? We're creating an employee with some ID, right? It's exactly the same code, right? Okay, let's see. It has less semicolons. Okay, so let's do roles, array of company role, employees. Right, and this is the point where sort of Scala is safer than Java, right? It says, hey, an array is invariant in type T. So even though this is exactly the same arrays as in Java, in fact, Scala, behind the scenes, it uses Java arrays, right? Still, the compiler is safer. Okay. In fact, to demonstrate that, I believe we can do as instance of, right? So we can sort of hack this, right? Okay. Let's see. I'm sorry, it has to be an array of company role. Array. There we go. Okay, so now it compiles, but it will end up resulting the same situation as we had before. Now, the way you access or you add things to an array is like this in Scala. Consultant. Oh, come on, consultant. All right. Another ID. Okay. Some company over here. Okay. Let's see. All right. Okay, array store exception, exactly the same thing, right? So if we turn the compiler off, basically, then we get exactly the same thing. Okay, and the last line was employee equals employees 0, like this. And let's just make sure that it compiles, because we just wanted to see that it compiles, right? So same as in Java, this code compiles if we do this nastiness. Okay, as soon as we remove that, the compiler is going to help you out. So be very careful with those as instance of. Very, very, very rarely you actually need them. But this is like a very, very advanced level of Scala, where you actually run into situations where you can't force the compiler, where you can't explain to the compiler that your types are correct, right? So basically, don't use them. All right, so we're pretty much at the end of this video. Now, why do functional programmers hate subtype polymorphism? Well, one of the primary reasons is that because basically it destroys types, and let me show you what I mean. So let me just throw out this example, right? And by the way, why does this should be like that? There we go. Okay, so look at this. Let's say we have a set of employee, which with some ID, right? Now, we wanted, from the very beginning, we started with, with union. Remember, we wanted to be able to add a consultant here. The problem is that we can also add anything we want. Look, this compiles. Now, this compiles and it actually works. Now, it is not an incorrect thing. It's just a very, very surprising thing, right? Because sets are immutable, right? So over here, what is happening? We have two sets. The first one is a set of employees, and the second one is a set of any. Because the Scala compiler, what it is doing here, it is looking. Remember, over here, it doesn't know anything about employees or consultants. When we go to add, right, it is looking for the common supertype of employee and int, and it finds any, right? So just to prove that to you, if I'm just gonna do that, and I'm just gonna annotate the type, right? This is exactly what's happening. Hold up, there we go. Right now, because this is confusing, there is a flag in the compiler that basically lints your code and warns you about situations like this. And yeah, this is one of the situations that it warns you about. So if you go to our build file, and we go over here and we add xlint. Now xlint is sometimes a little bit aggressive, so the same as it's probably -xlint, I'm not really sure. Now because it's sometimes so aggressive, it can also be like very granular, right? So you don't have to enable the whole xlint. You can also do xlint colon and then, you know, warn me about this, warn me about that, right? So the same as with language, you can also do language like everything, or, you know, just the implicit conversions. Okay, for now we're just gonna enable everything. Let me reload. Sorry that this video is getting so long. It's probably going to be a little longer than an hour. All right, so we actually don't care about testing. We just need to compile everything. So let's just do a test compile. Okay, so now it already produces some warnings. It basically says that okay, so it warns us that the private method unapply. Come on, scroll down. Private method unapply and object not empty is never used. Remember, we had those unapply things, those deconstructors over here, because we didn't want to be able to pattern match on sets, right? But we ended up not using them because this is sort of the purpose, right? We don't want to use them, which is why, you know, we make them private. So this is what I meant. You know, xlint like tends to be a little bit aggressive. So what's happening over here is basically exactly what I said. It says a type was inferred to be any. Come on, scroll down. It doesn't want to scroll down. Hold up. There we go. Okay, so a type was inferred to be any. And this may indicate a programming error. So it basically warns you that that over here that you might be making a mistake. Now it doesn't warn you here because you explicitly annotated, yeah, I know it's going to be any, right? But this can be confusing. Also, because, you know, most of the methods that we touched are doing the same thing. You can also ask. So let's say that we have a set of employees over here, right? By the way, notice that the warnings, they should go away if I, hold up, if I do that. Now, because we have incremental compilation, we didn't change anything here, so the compiler didn't have to, so the SPT didn't have to compile anything, and therefore the warnings went away, right? So it only shows the warnings of what it compiles, and right now it didn't compile that part. Okay, so let's say that we have a set of employee, and we can ask it if it contains an integer. You know, same as the equality thing. You know, so it's gonna compile. But over here again, it's going to say, hey, a type was inferred to be any. This may indicate a programming error. It's kind of cool. This doesn't always happen though. I'm not sure. Yeah. Anyway, another thing that you need to know is that in the Scala standard collection library, at least in the current one and not in the new one, I should have checked that before. Anyway, in the current collections library, sets are invariant, not because they should be, just because you know, historically it just kind of happened because of an implementation constraint, so to say. Yeah, so just one thing. No, all the other immutable collections are covariant, actually. Okay, now the very last code thing that I'm going to show you is, okay, we'll do test run. Okay, and it runs this one. So if you have a trait, let's just call it super, and it has a function called transform. Remember when we talked about, we never explicitly talked about function overloading, but at some point I started saying things like the signature of a method, and I said that the signature of a method is this part. It's not the return type, and it has a historical reasons, basically because, you know, in Java and, you know, other, you know, primary object-oriented languages like Java, generics didn't really exist, you know, in the beginning. We still needed something like this, right? So if we have over here an override def transform ID string, right, with a company role. Now this compiles, right? Oh yeah, I have to do something over here. right? So I don't really care about the implementation right now. I just want to show that it compiles. Now, because this is not part of the signature, and remember, a function 1 is contravariant in the first parameter, and it is a covariant in the second parameter, right? This means that if we go over here and we say employee, then it should work, and in fact it does, right? Which is kind of crazy, and most people, even senior developers, don't really know that. And usually you don't really need that. Like probably 99% of the time you don't really need that. Anyway, let's actually finish implementing this. Just for now to have a better example so that it actually works and not only compiles, because we've already seen a few examples where it compiles but actually breaks. So we're gonna have a higher order function over here, which takes a function that takes a string, produces an employee, and the whole function is a unit. Produce a unit, which is sort of a glorified version of println. Okay. So we're just going to create a range from 1 to 10, and we're going to map it, map every number to a string, and we're going to map it again to this function that we're passing in, and then we're just going to print out everything. All right, so this should compile, and now if we run the higher order function with sub.transform, it works. If we have company role over here, it doesn't. Now, obviously it doesn't because we set employee here, but if we do company role, then it works. Now, what's interesting is that if we don't go through sub, if we go through the type of super, right, then in this case it works. What about this one? Works as well. All right, so we finally arrived by the end of this video. So let me just say a few things. So when programming in a functional way, and I have so far never really clearly defined what it means, but basically, it's programming with immutable things and pure functions. Then mutability, which is something that is allowed in Scala, it breaks equational reasoning. Subtype polymorphism, it weakens the type inference. Then the variance, variance annotations, covariance, it tries to solve these problems, but even with variance, you still run into a situation where the type seems to be covariant and contravariant at the same time. Remember with our sets, actually set as a function, but they can't be like the same thing together, and we sort of got lucky with this magical implicit thing, right? So implicit came to the rescue, right? But believe me that implicits have issues of their own. In fact, I've shown you before, right? So it compiled, but then it caused some weird runtime loop that don't really know what it meant, right? So basically, all of this sounds that maybe some people interpret this as Scala is too complicated, as we should run away from Scala. But in fact, first of all, some people actually argue that those object-oriented features should be removed from Scala because they're so dangerous. Now, I would argue actually that Scala is not so complicated. In fact, it tries to solve complicated problems for you, right? So if you go, if you compare this with Java, I mean, basically, comparing it to Java is like taking a candy away from a kid, right? But still, like in Java, generics are horribly broken. They call side generics, they have like row generics. It's crazy. Over here, at least the compiler tries to help you out as much as it can with warnings, with fancy features. It tries to help you out as much as possible. So I don't think that we are in a as a Scala community that we are in such a bad position. It's actually so far from all the languages that attempted to blend object orientation with functional programming, Scala is probably one of the best ones, probably the best one. Yeah, and that's all I have to say for this video. I'm sorry that it was too long. I hope you liked it. I really hope that you understood it. And please try to play with this. Oh, in fact, we forgot to commit it. Let's commit it and push it. Now, just give me a second to remove all of these examples, and let me get back to you in a second. All right, so I removed all of the examples. Let's exit SPT now to git status. And this time we actually modified also the build file. Add everything, even though it's already added. Commit -am, and this is going to be video 7, and I'm just going to call it variance. All right, push, and I should need to unlock my key. There we go. Let's go to the web page, click on the commit. And let's see all the things that we changed. So we went to the build file and added those two flags. And by the way, notice that we haven't really changed any code today, right? So we just changed the types, which is sort of fascinating. And this sort of happens at the high level of, when you approach more and more to functional programming, types do a lot of work for you. Really notice, like over here, every time we're in the declaration part, every time we say final def, this is the line that was changed. Occasionally we helped out with type inference over here, but most of this, yeah, most of the changes are in the tests. All right, again, I hope you liked this video, and I really hope that you understood this. It is a probably one of the most complicated videos. So probably the most complicated video that I have made so far. The other one was about recursion, which was really it's one of those things that are really hard to understand and also like way harder to explain, which is a good way to learn. Like I actually I could have used this, this whole repetition, like this whole, one of the reasons why I started this YouTube channel was also to, to keep me also, sharp, to play with the tools that I should be using daily, and I should remember these. But in production, when you're writing like real applications, it depends on the programming style that you choose, but what we did today is not something that you do every day. Anyway, I hope you like this video. Like it if you did. Don't forget that. This helps me out a lot. And subscribe if you want to improve the developer inside you. And most importantly, take care.